radians and arc length of a circle. Working on a coordinate plane, we've already seen where the angle measures add up to 360 degrees in a circle. Now we're going to talk about the radians on the coordinate plane. Just so that you understand, if an angle has an initial side, a 90-degree angle in degrees would be a pi over 2 radian measure angle. A 180-degree angle would be pi radians. A 270-degree angle would be 3 pi over 2 radians. And a full 360-degree angle brings me back to 2 pi. Now the same things go for radian measure angles as degree measure angles. When you're going counterclockwise, it's a positive radian measure. When you're going clockwise, it's a negative radian measure. If you're ever given an angle in degrees, let's say you're given 180 degrees and you're trying to change it into radians, you're going to multiply it by pi over 180. In this case, the 180 would cancel and you'd be left with pi, and you label it as radians. If you're ever trying to change something from radians into degrees, using the same example but in reverse, if you're given pi radians, in order to change it into degrees, you're going to multiply by 180 over pi, because you want the pi values to cancel, and then you'll be left with 180, and you label it as degrees. If you're ever asked to graph an angle measure and its measure is in radians, if you're confused as to which quadrant it can go into, all you need to do is change it into degrees to figure out the answer to that. Let's say you're given a circle with a radius of 3 centimeters, and inside is a central angle with a measure of 270 degrees, and we're looking for the length in centimeters of this intercepted arc that the angle is intercepting. This intercepted arc we're going to refer to as S. Our angle measure is theta, but theta must be in radians. It cannot be in degrees, so we will have to convert it first. And then our R value is just our radius length. So in order to find the measure of S, we're going to do the angle measure, but in radians. So to change 270 into radians, we're going to multiply by pi over 180. 270 pi over 180 is going to reduce down to 3 pi over 2. So this is my theta value. So 3 pi over 2 times the radius, which is 3. This is going to give us 9 pi over 2. Normally these questions say round to the nearest. In this case, let's say that it says round to the nearest 10th. You're going to type into your calculator 9 pi divided by 2 and round to the nearest 10th, which in this case will give us approximately 14.1, and I'm going to label my answer as centimeters. In geometry, you've seen inscribed angles before where the measure of the arc was the same as the measure of the central angle. So the arc measure would be 270 degrees, but here we're actually looking for the length of the arc. So we're looking for the centimeter value. In other words, if I were to unravel this piece, what would the measure of it be? So you need to use theta as radians, R is the measure of the radius, and S will give you the length of this arc. Make sure you label your final answer and you round to whatever place they ask you to.